we will discuss about elementary operations of a matrix. In the short form, it is called as E operations also, and it can apply for both rows as well as for columns. So the first operation is, that is the interchange of any two rows. First, if we are talking about the rows, right? Interchange, as you know, what do you mean by interchange? Like if we are taking the two rows, the first row and the second row, and we will interchange that rows, right? So that means the second row will become the first one and the first one will become the second one, right? For example, I have written here that is r to the base I. It means this is interchange r to the base j. It can be any number, depends on the matrix, like how many rows we are having in the matrix. So I will discuss it by taking one example here. As you can see that this is the matrix A and this matrix has 3 rows, right? So if I'm taking I as 1 here and J as 2, so just put, this was the first operation, that is Ri interchange with Rj. Now I'm taking I as 1, J as 2, right? So this will be R to the base 1 and J to the base R to the base 2, right? So it means R1, that is the first row, will interchange by R2, that is with second row. So third row, there is no operation on the third row, so third row remain as it is. First I will write the third one, that is 3 minus 1 and 11, right? So this row remain as it is. Interchange the first and second. Now 1 interchange with 2, it means the 2 second row will become the first one, right? So the first one will be 2 minus 1 and it will be minus 1. This was the second row, and now the first row will become the second one, that is 3. The second element of that is 2. Now next is 3. All right, I hope you got this, the first operation. The same operation we can apply to the column as well, like the interchange of any two columns, as same as C to the base I interchange with C to the base J. The example I have taken here, same, I will take I as 1 and J as 2. It means the first column will interchange with the second one, that is C to the base 1 interchange with C to the base 2. No operation on the third column, so it will remain as it is, that is 3 minus 1, 11. Right? Now the first column will become the second one, so it will be 3, 2, 3, and the second column will become the first one, that is 2 minus 1 minus 1. So 2 minus 1 minus 1, right? So this was the first operation. Let's move to the second one. Again the same operation we can apply for rows as well as for columns. So the operation is the multiplication of the elements of any row by a non-zero number. Like any row, we can multiply one row in the matrix with any non-zero number. Same operation with column also. So let's solve it by taking one example here. Suppose this is a matrix, right? 3 rows are there. So I'm just writing, take one row. I'm taking the first row and I will multiply the first row as with 2. What is 2 here? Scalar. So I'm just applying the operation on the first row. You can apply it on the second as well as on the third. All depends on the number of rows in the matrix. So I'm applying the operation on the first row. It means second and third remain as it is. So the second will remain as it is and the third one also. That is, the third row is 3. This is minus 1 and this is 11. So the first row will become, after multiplying with 2, every element in the first row. So 3 2s are 6 and 2 into 2, that is 4, and 3 into 2, that is 6. All right. Same, let's move to the column. Same operation, but now we will apply the operation on column, right? Same, like I am taking here to the base 1, means I am applying the operation on column 1. You can apply for in column 2 as well as column 3. All depends on you according to the condition, right? So this is like second and third column remain as it is, that is 2 minus 1 minus 1, and the third column is 3 minus 1 and 11. All right, now what will be the first column after multiplying with 2 every element? This will be 3 into 2 is 6, and next is 2 into 2 4, and 3 into 2 6. All right, I hope you got the second operation. Now the third one, right? So the third is, again we will apply the operation rows as well as on columns. The addition to the elements of any row, the corresponding elements of any other row multiplying by any non-zero number. Like if we are taking one row, it will add and subtract, and it is adding and subtracting to the other row, and that row can be multiplied to any non-zero number, right? So let me I hope it will be clear more by taking one example. Yes, you can see here this one, like r to the base I is equal to, that is implies r to the base I plus minus, like we can add or subtract, like we can add and subtract r to the base I, and what is k here, any scalar, and what is r to the base j, this is any other row, right? So let's solve it by taking one example. This is a matrix A, and now I am applying the operation here according to this, right? So I am taking I as 2, and this is the first row, like whatever I have written this row na, that row only that row will be changed, not the second one. So I'm just writing here r1. Why I have written here? Because the first element you can see the of the second row, that is 6, right? And when we multiply the first element of the first row, that is 3, 3 into 2, that will be 6, and when we subtract the first element of the second row, 6 minus 6, that will be 0. So according to the condition, we can apply the operations, right? So just for this, you need to know how we can apply the operations first. All right. So here, as I have already said that only second row will be changed, but row first and row third will remain same. So let me write these rows first, because this will not change, because we will apply the operations on only second row. So the first remain as it is and the third remain as it is. All right. So now just apply the operation. Yes, what is this? R2. As I can write here, that is what is the first element of R2 here? That is 6, right? So I can write here 6 minus, according to this, minus this will be 2, and what is the first element of R1? That is 3, right? So now you can see that this will be 6 minus 6, 6 minus 6, that is 0. All right. So what will be the, after applying the operation, what will be the first element of the second row? That is 0. All right. So with the same method, you can solve, you can find the other entries as well. Like this is minus 1 into, again we can solve this. Yes, let me clear this one first. All right, now we can solve this again for the second entry, that is minus 1, the second entry of the second row, minus 2 into the second entry of the first row, that is 2. So when you solve this, it will be minus 1 minus 4, that is minus 5. All right. So now we got the second entry as minus 5. Similarly, we can find the third one. Yes, you can tell me what will be the entry of the third one. That is the third element of the second row, that is 0. 0 minus 2 into 3, that is 6. So it will be minus 6. All right. I hope you got this operation. The same operation we can apply on the columns as well. Like suppose we are having this example, same operation I will apply to the columns as well. So now you can see that I am applying the operation on the second column. So first and third remain as it is, right? and this 2, this one is 3. The third column remain as it is, so it will be -1 and this will be 11, right? Now second column will be changed. Now second column, the first entry of the second column, that is 6. So it will be 6 minus, according to the operation, minus 2 into the C1, the first entry of the first column, that is 3. So 6 minus 6, that is 0, right? So it will be 0 here. The same we can find the other entry by applying the operation, that is -1 minus 2 into 2, second entry. So it will be -1 minus 4, that is -5. All right. Same, the third entry we can find 0 minus 2 into 3, that is -6. So we can write the next entry as well, that is -6. All right. I hope you got all the operations. So we have discussed 3 operations, right? So you can apply the operations on any row, any column. So thank you so much.